Okay, in this video, we're going to be doing AP Calculus Review Quiz number 4. Let's take a look at the questions. Number 1, given that f prime of 3 is 0 and f double prime of 3 is 5, what can you conclude about f of x at x equals 3? And we want to justify that. So, we know that there's a critical point at 3. We know that this thing is concave up at 3, but that's really not the main conclusion that we can draw. I'm going to say that this tells us that we have a horizontal tangent line. This fact tells us that we're concave up. So I'm going to draw a little thing there. You can definitely conclude that we have a relative minimum at x equals 3. We need to justify that. So I'm going to say, because of the givens, basically, f prime of 3 is 0, f double prime of 3 is greater than 0. And then if you want, you can cite it by name. We are using the second derivative test on this. So that's really what you would want to conclude based on the given information here. Let's take a look at the next question. So number 2, given that g prime is the quantity x minus 3 to the 4th, the quantity x plus 2 cubed, the quantity 3x minus 2, find the x coordinate of each relative maximum of g of x. So this to me is definitely a sign chart problem. So let's make a sign chart. So it's going to be for g prime, the zeros of g prime are positive 3, negative 2, positive 2/3. Make sure you put them in order on that sign chart. Otherwise, you're going to have a lot of trouble. So what I'm going to do is I'm going to plug in negative a billion and see what it gives me. So negative billion gives me positive from that first thing, a negative from the second thing, a negative from the third thing. So that's positive, negative, negative. 2 negatives give me a positive overall. So I'm going to fill that in. Now, negative 2 comes from a third degree factor, or a multiplicity of 3, so there's going to be a sign change, so we'll go negative here. 2/3 comes from a first degree factor, so there will be a sign change. Anytime it's a odd power for the factor, there will be a sign change, so we go positive here. Positive 3 comes from a factor with a degree of 4 that's even, no sign change. Or if you prefer, you could just plug values in. That's totally up to you. I like to do it this way. So actually, the only place that we have a change from positive to negative in g prime is at x equals negative 2. So that will be our relative max. So relative maximum at x equals negative 2. And our reason will be because g prime changes from positive to negative there. That's the answer to this question. All right, let's take a look at number 3. Evaluate the integral of 1 over x natural log of x dx. So first thing I do is I look at this and I think, this is probably u substitution. I'm going to make u equal not x natural log of x because the derivative of that would be complicated. I'm just going to choose natural log of x. So this is from experience. You want to do a lot of integrals, antiderivatives before you get to the AP exam. I need to figure out what du is. So du is going to be 1 over x dx because the derivative of natural log is 1 over x. Now I'm just going to make my substitution. So we have, there's our u, it's in the denominator, so I'll make it 1 over u. And then the rest of this stuff, right, we got 1, dx, and x, that's all just going to be du. So we have to integrate 1 over u du. We know that that's the natural log of the absolute value of u. So natural log, absolute value is essential when you do this. And then there has to be a plus c. Never forget the plus c. Now we're just going to substitute back in u is equal to natural log of x. So we get natural log of the absolute value of the natural log of x plus c. It's a weird looking answer, but you don't get to choose how weird the answer looks. You just do the work correctly. Let's look at part B of this question. So we want to evaluate integral of sine of 2x over 1 plus cosine squared of 2x dx. Again, we have to make a choice. You could try to make u equal the whole denominator, but again, the derivative of 1 plus cosine squared of 2x is complicated. It's way more complicated than just sine of 2x. So I'm going to instead choose cosine of 2x because I'm thinking that this looks a little like an arctan situation. du is negative 2 sine of 2x, right? So the negative 2 is coming, well, not the negative. The 2 is coming from the chain rule. The negative is coming because the derivative of cosine is negative sine. So negative 2 sine of 2x dx is du. So what I'm going to say instead is negative 1/2 du is sine of 2x dx. The reason I'm doing that is that I have sine of 2x dx that I need to sub for. So at the outset, I'm thinking I have 1 over 1 plus u squared And then sine of 2x dx right there is negative 1/2 du. Pull out the negative, put the du at the end. We're good to go. This is definitely arctan. So I will say it's negative 1/2 and then arctan of u plus c. And then we just substitute our u, which is cosine of 2x. So we get negative 1/2 arctan cosine of 2x plus c. All right, let's take a look at the next one. Number 4, I want to find the area of the region in the first quadrant. So that's important, first quadrant. Bounded by the coordinate axes and the graph of y equals e to the 3x and x equals 2. All right, so I'm going to start with a graph. So generally speaking, you want to graph this as best you can. It doesn't need to be perfect. Figure out the region, set up the integral, and then do the integral. So we have that. Here's x equals 2. So our region is just kind of the shaded region here. So I'm going to say we're doing the integral from 0 to 2, top curve e to the 3x, bottom curve 0 dx. I would encourage you every time you're doing like find the area problems to do the integral from left to right of top take away bottom. Even if the bottom curve is y equals 0, just put it in, because then when it's not, you'll be used to doing it. And then obviously minus 0 isn't really impacting anything. We're going to find the antiderivative of e to the 3x, which will be 1/3 e to the 3x by the chain rule, reversing the chain rule, I guess. And then from 0 to 2, and then that'll be 1/3. When we plug in 2, we get e to the 6th. When we plug in 0, we get e to the 0. Now, it's really important that e to the 0 is not 0. A lot of times people get a little overexcited by plugging in 0 and just zeroing everything out. Not the case. Watch out especially for e to the x and cosine of x in those scenarios. So this will just give us 1/3 the quantity e to the 6th, and then minus 1. All right, let's take a look at the next problem, number 5. We want to find the area of the region bounded by the curve f of x equals x squared minus 3x plus 5, and g of x equals 2x plus 1. So I'm going to start with a picture again. Again, doesn't need to be perfect. I have a quadratic that opens up. That's f of x. I have a line with a positive slope. That looks like that. If these are going to intersect, it basically has to look like that, right? The line couldn't be below the quadratic or they just wouldn't intersect. So I'm going to need to find these intersection points, which means I need to set the functions equal. So I'm going to just do that. Set them equal. I'm going to move everything to one side. I'm going to factor. I'm going to set it equal to 0. Find x equals 4, x equals 1. Now let's set up our integral. So it's going to be the integral from left to right, which is 1 to 4. Top curve, which is g of x, so 2x plus 1, minus bottom curve, which is f of x, so that's going to be x squared minus 3x plus 5. And then we have a dx. We're going to combine that, clean things up before we integrate because it just makes life easier. So 1 to 4 of negative x squared plus 5x minus 4. It's all reversing the power rule, so plus 1 times the reciprocal all the way through. With this, we got 5/2 x squared, we got minus 4x. We are going from 1 to 4, and then this is kind of an annoying thing. We have to plug in 4, so we get negative 64 over 3. Then you get 16 over 2 is 8 times 5 is 40, and then you get 16. Then minus, we got to plug in 1, so negative 1/3 plus 5/2, and then minus 4. I like to simplify these in like the easiest way possible. So what I'll do is like look for the things that have a denominator of 3. So negative 64 minus negative 1 is negative 63 over 3 is negative 21. And then these combine already into 24. And then it's minus negative 4, so plus 4, so that's 28. And then this just has no partner, so minus 5/2. So that's 7 minus 5/2, 14 minus 5 over 2. 9/2 is our answer. All right, let's take a look at question number 6. It's got 3 parts. The particle moves along the y-axis. Acceleration is 6t minus 3, such that v of 2 is 4 and y of 2 is 5. We want to find v of t, so let's set that up. V of t is definitely just the integral of a of t, dt. All right, so that'll give us this integral. Just reversing the power rule, so it's going to be 3t squared minus 3t. A lot of people forgot plus c on this one. That's terrible. We can solve for c. I mean, you have to solve for c. Why are they telling you that v of 2 is equal to 4 if you're not going to use it, right? So we're going to solve for c. V of 2 is equal to 4, which means that 4 is equal to 3 times 4 minus 3 times 2 plus c. And then that'll tell us that c is negative 2. And therefore, v of t is 3t squared minus 3t minus 2. All right, that's the answer to that. Let's take a look at part B. Is the particle speed increasing or decreasing at t equals 1? And then we want to justify that. So we need the velocity that we found last time. We're going to find v of 1 and a of 1. So v of 1, we just plug in, right? 3 minus 3 and then minus 2. So negative 2. And then a of 1, we're going to plug into 6t minus 3. So 6 minus 3 is 3. So velocity and acceleration have opposite signs. Speed is definitely decreasing. So I'm going to say speed is decreasing at t equals 1, and then I will give a reason. It'll be v of 1 and a of 1, which I found, and I showed those values already. I think that's an important step. But v of 1 and a of 1 have opposite signs. All right, we got one more in this. So let's take a look. Approximate the particle's position at t equals 2.2 using a locally linear approximation based on the given information. Locally linear approximation just means tangent line approximation. It's a weird, in my opinion, a weird way of asking the question, but it's pretty common to ask it that way. So we're going to write the equation of the tangent line. Tangent line. So we know that y of 2 is equal to 5, so it's going to be y minus 5 equals, the slope is v of 2, which is 4, and then t minus 2. So we're asked to approximate y of 2.2, basically. Y of 2.2 is going to be approximately 5 plus 4 times 2.2 minus 2, which is 5 plus 0.8, or 5.8. All right, that's the whole thing. I hope this was helpful, and good luck.